Alliance Space Systems is a small company in Pasadena, California. And the three founders were JPL employees, and they decided to start their own company, but doing the same work they had been doing there. And NASA, in the middle to late 2000, decided that they wanted a mission for 2003. The Mars opportunity involving not only one spacecraft, but two spacecraft, two rovers, and they knew they wanted a robotic arm on this rover. And they said, we need this in our hands in 18 months. And basically we're starting from something that somebody drew on a whiteboard to them wanting something that's going to work on Mars in 18 months. But, you know, we're all excited and crazy and just said, sure, that sounds good. When do we start? We started working with them. The answers were always coming back. It needs to be really, really small and really, really light and really, really capable. We used Solidworks right from the beginning, and in 3D sketched out a bunch of different concepts, a bunch of different ideas, and we worked with JPL of, will this work, and the scientists. What kind of arm does this need to look like? Does it need to have an elbow? Does it need to have an elbow that does this? Does it need to have a wrist that does this, or should it do this? We had 5 design engineers, 2 analysts to do the stress and structural analysis and also the dynamics analysis associated with the problem. And SolidWorks, obviously, right from the beginning was key in terms of an intuitive design tool, something that you could visualize very quickly. And then the integration of CosmosWorks, which is the analysis package, was fundamental in allowing our design engineers to, as they were working through these problems, to make the best parts that they could make and iterate on those over and over again with getting real-time feedback from these tools. By July, we had a detailed design completed, and then we had the daunting challenge of taking this arm, which at this point had 300 unique parts, all custom, all one of a kind, and all never before made. Take all of those and make the engineering drawings that could be sent to machine shops for those. All of this had to be done in the context that we were searching for every gram, we were searching for every millimeter of space. With SolidWorks, we were able to measure the fractions of a millimeter in the tool, and they would literally be within fractions of those fractions in real life. And it's that confidence that we had in the tool, that what we were putting into the computer was what was going to come out on the back end, was key. Along the same lines as the Cosmos and SolidWorks methodology in terms of a paperless type of workflow, we decided to use a paperless drawing system as well. In 5 months, we had successfully basically put the entire drawing package, documented the entire design with basically those same 5 engineers. And then we were looking at building about 4,000 unique parts in about 5 months. When I first saw the first parts come out of the machine shop, and I held them in my hands, and they looked exactly like they did on the screen, and the SolidWorks part matched exactly the part that was in my hand, that was pretty remarkable. Because I knew that where this part was going to end up, and then we had to put it through a rigorous series of testing. We had to make sure that it could survive launch, survive landing, which was extraordinarily harsh. We had to make sure that it could survive the temperature extremes of Mars. And we would have loved to have tested it for much longer, but obviously JPL is now clamoring for getting their hands on this arm. And then we kind of helped support them while they were trying to integrate it with the rover. And that was in November of 2002, and they launched the following June and July. And to see it again, but on another planet, so many months later, and it looks just like it looked when you left it, except the background scenery is quite a bit different. It was exhilarating. I mean, words just can't describe. I don't think this project would have been possible without SolidWorks. On the scale that we were at, in the time frame that we were in, there was no other solution in my mind that would have taken us where it took us.